Hello, students. Happy Diwali to you all because I'm taking this lecture before Diwali. So I'm saying Happy Diwali. I hope you enjoy Diwali. And now we will start with the next part. In the last lecture, we have completed this part, that is, there are three basic principles of experimental design, that is replication, randomization, and local control. And we have seen all this in detail. We will just see a small video on that.
अस्सलाम वालेकुम स्टूडेंट्स। तो आज हम बेसिक प्रिंसिपल्स ऑफ एक्सपेरिमेंटल डिजाइन को डिस्कस करेंगे। एक्सपेरिमेंटल डिजाइन के हमारे पास थ्री बेसिक प्रिंसिपल्स हैं, रैंडमाइजेशन, रेप्लिकेशन और लोकल कंट्रोल। सबसे पहले हम रैंडमाइजेशन को डिस्कस करते हैं। तो जैसे कि इसके नाम से ही पता चल रहा है कि किसी भी चीज को रैंडमली अप्लाई करने का प्रोसेस जो है वो रैंडमाइजेशन कहलाता है। तो जब भी हम कोई एक्सपेरिमेंट परफॉर्म करते हैं और उसमें ट्रीटमेंट्स को एक्सपेरिमेंटल यूनिट्स पर बिल्कुल रैंडमली अप्लाई करते हैं तो उस प्रोसेस को रैंडमाइजेशन कहते हैं। रैंडमाइजेशन जरूरी क्यों है? रैंडमाइजेशन हमें प्रोबेबिलिटी थ्योरी की तरफ लेकर जाती है और प्रोबेबिलिटी थ्योरी जो है वैलिड स्टैटिस्टिकल इन्फ्रेंसेस ड्रॉ करने में हमारी हेल्प करता है। अगर प्रोबेबिलिटी थ्योरी नहीं होगी तो हम वैलिड स्टैटिस्टिकल इन्फ्रेंसेस ड्रॉ नहीं कर सकते। सेकेंड हमारे पास है रेप्लिकेशन। रेप्लिकेशन का मतलब है कि एक एक्सपेरिमेंट को बार बार रिपीट करना। ये हम इसलिए करते हैं ताकि एक्सपेरिमेंटल एरर को रिड्यूस किया जा सके। एक्सपेरिमेंटल एरर क्या है? एक्सपेरिमेंटल एरर ये है कि हम सेम ट्रीटमेंट सेम एक्सपेरिमेंटल यूनिट पर अप्लाई करते हैं लेकिन हमारे पास आंसर डिफरेंट आता है। फॉर एग्जांपल आपने देखा होगा कि जब आप एक रेसिपी ट्राई करते हैं तो पहली दफा में समटाइम्स उसका टेस्ट डिफरेंट होता है और जब आप दूसरी दफा ट्राई करते हैं तो उसका टेस्ट डिफरेंट होता है, जबकि आपका मेथड बिल्कुल सेम होता है। जब आप वही रेसिपी रोज रोज बनाओगे तो टेस्ट सेम होता जाएगा। जैसा कि आपने देखा होगा कि होटल्स में खाने का टेस्ट हमेशा सेम ही होता है। वो क्यों होता है? रेप्लिकेशन की वजह से होता है। और थर्ड हमारे पास है लोकल कंट्रोल। लोकल कंट्रोल में हम क्या करते हैं कि हम ब्लॉकिंग कर लेते हैं। ब्लॉकिंग का मतलब ये है कि हमने जो भी ब्लॉक्स बनाए हैं उस ब्लॉक के अंदर हम जो भी ट्रीटमेंट टेस्ट करना चाहते हैं वो ट्रीटमेंट का एक फुल सेट आए। फॉर एग्जांपल कि अगर हमारे पास तीन प्लॉट्स हैं ए, बी और सी और हमारे पास तीन टाइप के ट्रीटमेंट्स हैं, मतलब हमारे पास तीन टाइप के ऑरेंज ट्रीज हैं, टाइप 1, टाइप 2 और टाइप 3। और अगर हमने प्लॉट वाइज ब्लॉकिंग की है तो इसका मतलब है प्लॉट ए में तीनों टाइप के ट्रीटमेंट मतलब टाइप 1, टाइप 2 और टाइप 3 के ऑरेंज ट्री आएंगे। इसी तरह प्लॉट बी में और इसी तरह प्लॉट सी में भी आएंगे। ब्लॉकिंग हम करते इसलिए हैं ताकि हम एक्सट्रेनियस सोर्स ऑफ वेरिएशन को खत्म कर सकें। सोर्स ऑफ वेरिएशन ये है कि जैसा कि आपके पास ए, बी और सी तीन प्लॉट्स हैं। अब जो प्लॉट ए है उसका लैंड भी फर्टाइल है और उस पर सनलाइट भी अच्छी आती है, लेकिन जो प्लॉट बी है उसका लैंड तो फर्टाइल है लेकिन वहां पर सनलाइट इतनी अच्छी नहीं आती। और जो प्लॉट सी है उस पर सनलाइट तो अच्छी आती है लेकिन उसका लैंड फर्टाइल नहीं है। तो अब अगर आप टाइप 1, टाइप 2 और टाइप 3 के ऑरेंज ट्रीज को बिल्कुल रैंडमली अप्लाई करेंगे तो इट माइट बी पॉसिबल कि जो टाइप 1 के ऑरेंज ट्रीज हैं वो सारे प्लॉट ए में आ जाएं और बाकी प्लॉट बी और प्लॉट सी में। तो अब जब आपके पास रिजल्ट्स आएंगे तो हो सकता है कि जो टाइप 1 का ऑरेंज ट्रीज थे उसके रिजल्ट ज्यादा अच्छे आए क्योंकि उसका लैंड भी फर्टाइल था और वहां पर सनलाइट भी अच्छी पड़ती थी। लेकिन ये वैलिड रिजल्ट्स नहीं होंगे क्योंकि हो सकता है कि अगर टाइप 2 और टाइप 3 को भी लैंड फर्टाइल मिला होता और वहां पर सनलाइट अच्छी आती तो वो टाइप 1 से भी ज्यादा अच्छे रिजल्ट्स जनरेट करते। तो इस टाइप की वेरिएशंस को खत्म करने के लिए हम ब्लॉकिंग यूज करते हैं।
So you have seen what is randomization, replication, and local control with example. Now we have also completed in the last lecture that how many important experimental designs are there. There are two, that is formal and informal. And we have seen what are the different, we have seen that what is informal experimental design and what is formal experimental design. Informal experimental designs are those designs that are normally use a less sophisticated form of analysis and which is based on differences in magnitudes, whereas informal uh, experimental design, it is relatively more controlled and use precise statistical procedures for the analysis. So more precise is always formal experimental design. We have seen that there are four types in informal experimental design and there are four types in formal experimental design. Those we are going to discuss in detail now. So first we will see informal experimental design, in which the first one is before and after without control design. Now, the name itself suggests that it is such a treatment or it is such an experiment where there will be a study before and after, and there will be no control will be kept. So in such design, generally there is only one single test group is there, or single test area is there, which is selected. And everywhere in all these designs, we are going to see the effect of dependent variable, or we are going to measure dependent variable. Now, here in this case, we are going to measure dependent variable before the introduction of the treatment, and then we are also going to measure the dependent variable after the treatment. So you can just see this chart where the test area is selected. Now, whatever phenomenon that you can take, any kind of phenomenon like plotting the plants with the fertilizer. So the first is level of phenomenon before treatment. So no fertilizer is applied here, that is X. Then treatment is introduced, in the sense you have applied a particular fertilizer in that particular field or in that particular area of the field, you can say block of the field. And then if you want to find out what is the effect of treatment, so to find out treatment effect, what you have to do, find out the treatment which you have given after, or the treatment which you have given with fertilizer minus the treatment which was, or whatever the phenomenon or condition of the crop before you give the treatment. You have to make the subtraction from after treatment minus before treatment, and then you will get actually the whatever effect of that particular treatment is there. Now, the main difficulty of such design is that with the passage of time, considerable extraneous variation may be there in this treatment. As I said, we are seeing only the effect of fertilizer, right? You have seen effect of fertilizer just for 1 month or 2 months, but or you can also see the effect for 6 months. But there are many extraneous factors, that is the original soil fertility, then light, then water, whatever type of water you are giving, or uh, it may affect even because of seed quality, whatever seeds you are using. Although you are using the same seed, there are few seeds which are not always good, so that may affect. So that extraneous variation may occur in this particular design. Then the next one is after only with control design. Now the name again, it suggests that there must be a control group, right? So in this particular design, there are always two groups or areas, right? One is called as test area and the other is called as control area, which you have to select. Then introduce the treatment into test area only, because control will remain without treatment always, right? It is acting as a control. And then you have to again measure the dependent variable, not only in the test area, but you have to also measure it into the control area itself. So you can see this design, this is the test area. There are two groups, one is test area, another is control area. Then introduce the treatment. Now you are going to introduce this treatment only and only in test area. So whatever level of phenomenon is after treatment is going to happen, just note it down as a Y, right? And then you are going to keep the control area as it is. You're not going to give any treatment to the control area, but you are going to even measure the control area after a particular time period, that is after 6 months, suppose. Again, we can take the example of fertilizer. You applied the fertilizer to a particular test area. You have also taken another area which will act as a control, right? Another block, you can say, and given the treatment to the block X or block Y, you have given the treatment. Block Z will remain as it is, right? And then just minus whatever the effect of treatment minus the control. So here you are just nullifying whatever is the effect of control giving in that particular treatment. You are subtracting that effect of control from the treatment. So whatever you are going to get, it is always will be the only effect of the treatment. So the basic assumption in this particular design is two areas are identical. So whatever areas you are selecting, they must be identical with respect of their behavior, in the sense with respect of the soil fertility and towards whatever the effect of fertilizer will be there. So that particular phenomenon is considered that the effect will be same. Now, if this assumption is not true, that is the soil fertility or some extragenous variation is there, then there is a possibility that the treatment effect may vary. So, however, the data can be collected in such design, and the problems can then be maybe get reduced as the time passes. That is, instead of 6 months, if you repeatedly give the treatment, then might be the soil fertility affect everywhere equally. So, and the crop which you are going to get, the result will may be same. So this particular design is superior to before and after without control design. Then the third is before and after with control design. So now here also, again, in this particular design, you have to select two areas, and again you have to measure the dependent variable in both the areas. Of course, these areas you are considering that they are same, and you are also going to measure the treatment for the exact or identical time period for both the areas similarly. The treatment is then introduced into the test area only, obviously, and the dependent variable is measured in both for the identical time period. So for a particular time period, you are going to measure that particular treatment. So you can just see the treatment effect is determined by subtracting change in the dependent variable in the control area. So you're going to subtract the control area reading from the whatever treatment you have given, right? So you will just see this chart in which the test area is there, where level of phenomenon before treatment is measured, which you just name it as X, right? Then the control area, where the level of phenomenon without treatment, right? This is before treatment. Why it is called as before treatment? Because in this particular area, the treatment will be given afterwards, right? And why it is called as without treatment? Because in this particular area, that is control area, no treatment will be given even after 6 months, right? But it will get measured. So the test area, again, we can take the example of fertilizer. This is the test area. This is the level of phenomenon, means the soil which is tested before the crop yield is tested before any treatment of fertilizer, right? And with that, a control area is also taken, where the level of phenomenon without treatment. So it is also at this phase, they two are actually same, right? So but the only thing, one will get under treatment and another will not get treated at all. So this test area is named as X and the control area is named as A. Now introduce the treatment into the text area, right? Test area. And for this is for time period. This is, you can say, initial time. And this is time period second, in the sense it is after 4 months, right? Then find out the level of phenomenon. What changes have happened to the crop? Whether the crop yield got more as compared to the previous whatever 4 months crop is there, and whatever previous yield of crop is there, just compare it, that after the treatment of the fertilizer, whether it has increased or not. So just give it as a Y. And then the control area, it's no treatment is given. Whatever crops are growing there, the same crops will be observed after 4 months. And that before uh, before treatment or without treatment, it is called as A. And after 4 months, just observe the time period for the growth of that particular plant, and that is Z. So now if you want to find out treatment effect, just minus Y just subtract x from y and again minus it from z minus a. So whatever controlled variation will be there, that all you are just subtracting it from the effect of treatment. So final whatever effect you are going to get is near to the accuracy, right? It's more accurate data you are going to create, and thus this is the superior design to all the both of the above design. Now the last one, that is ex post facto design. In this, generally researcher identifies events which has already occurred or the conditions which are already present. You cannot change it. The researcher cannot change any condition, right? But what the researcher can do, it can collect the data and investigate the possible relationship between the factors or subsequent characteristics or behaviors, that all it can relate and find out some conclusion. So when such kind of research is there, this ex post facto design has to be done. So in many situations, such as it is not possible, it's unethical or impossible to manipulate certain variables. For example, a researcher want to study or prepare a vaccine for deadly new virus, but to study it, can researcher intentionally infect people with that deadly virus and find it out what is the effect and which part exactly of that virus is causing the infection, how that virus is entering, and can I modify that particular part and prepare the vaccine? He cannot do that. He cannot actually infect intentionally the people, right? In such scenario, the only thing that he has to prepare the medicine and then introduced it into the mice, first do the clinical trials, and then only can see the its effect on the people. So others are earthquakes or tsunami. Before situation, right? The researcher know that before this was the scenario, and after the tsunami or earthquake, what has happened. So he can just compare and find out the effect, that before it was so good, afterwards it was destroyed, or what at what level of destruction has happened. So this type of ex post factorial design is also called as casual comparative design. It has another name too. Now another example, we can take that if a child is delinquent, in the sense that it is involved into the criminal activities, then in order to find out that what is the reason behind its criminal activities, researcher can do the study of that particular child. How it will try to find out what is its history, family history, then how its behavior in the school, how he is behaving with the peer, whether those peers or the friends are affecting, whether neighbors are affecting, how the social life of that particular child is, and what behavioral changes that particular child has as compared to the normal child. And then interpreting all this, it could go to some conclusion that the particular child has developed this criminal behavior or does criminal activities because of these points. It is not having good family history, its friends are not good, they are criminal, they taught him that, or it's not following, and because of that it is also not following any school discipline, or else it is having some psychological issue, and because of that it is doing all the criminal activities. Now here the researcher cannot do any variation uh, in that particular child or whatever. Everything is there, right? The researcher has to only find out the reason. It has to find out that what is the cause behind the activities, and for that the researcher has to just predict the cause on the basis of controlled effect. Controlled effect means this has already done, nothing can be done, right? And he has to just study and give some conclusion. So whenever such kind of research is there, the design of that particular research is ex post facto design. And then thus this post facto research can be defined as an empirically based investigation, which actually does not involve the researcher's direct control, because here no, whatever examples we have seen on in case of earthquake, tsunami, or even this child, you cannot control anything, right? There is no direct control over the independent variables. Why? Because the effect has already done, the criminal activity has already done by the child. Now you cannot control its criminal activity. Of course, the next criminal activities you want to control, so you will study it. Or earthquake is done, tsunami has already happened, now nothing can be changed. So thus, because they have already led to the effects, which can no post facto research more be manipulated. So in this particular research, you cannot manipulate. In others, if you see, you can change the variables or independent variable, dependent variable, you can change and find out what can be the effect. Here, nothing you can manipulate, you just find out the relations, whatever happened already. Now, these are again few examples of the casual comparative research or ex post facto research, where in the first you can comparing the academic achievement of the first grader who have attended kindergarten versus those who did not. So they have already, some of them have attended, some of them have not attended already. Now you cannot just make them attend again, right? Or do something else in that case. So you have to just compare and find out whether those who have attended kindergarten are better than those who did not. Then comparing whole language reading scores of second graders versus traditional basal scores of the second graders. So those who have having special training or who have already taken some special training in language reading, are they scoring good in particular second graders versus traditional, those who are traditionally basal scores of second graders? Just compare between them. Then academic achievement of the second graders from broken homes versus academic achievement of the second graders from non-broken home. Broken homes can be because of divorce or because of some even earthquake or tsunami, they have just lost their parents, or they are in some orphanage. So is there any effect from those second graders which have broken homes and those who are not having broken? So you cannot change anything, you have to just compare and study it. When such kind of research is there, it is called as ex post facto casual comparative research. Now there is actually one
Hello,
video
students. Today we are going
which you can just go through it. Let's see how many minutes are remained. Okay.
Hello, students. Today we are going to discuss types of experimental research, part 1. In the previous video lecture, we discussed the concept of causal research design. Today we will discuss the types of causal research design in detail. Causal or experimental designs are the plans which provide guidelines to conduct the final experiments. And there can be two broad categories of experimental designs, that are informal experimental design and formal experimental design. Informal experimental design uses four methods or designs, that are before, after, without control, before, after control, after only with control, and ex post facto design. In this video lecture, we will discuss the types of informal experimental design. Let us recall the meaning of experimental research design again. In the previous video, we studied that experimental research designs are concerned with the examination of effect of the independent variable on the dependent variable, where the independent variable is manipulated through the treatment, and the effect of those treatments are observed on the dependent variable, and the researcher have complete control over the extraneous variable. Now we will see the various types of experimental research design with conceptual diagram in the next slides. The first method of informal experimental research design is
before, after, without control group. In informal experimental designs, most of the effects of the experiments can be quantified. In before-after design, a single test group or area is selected and the dependent variable is measured before the introduction of the treatment. The treatment is then introduced and the dependent variable is measured again after the treatment has been introduced. The effect of the treatment would be equal to the level of phenomena after the treatment minus the level of phenomena before the treatment. As we have already discussed in the previous video, that there are two groups in experimental research. What are these two groups? One is experimental group and second is control group. What is experimental group? Experimental group वह ग्रुप होता है जिस पर कोई ट्रीटमेंट अप्लाई किया जाता है और उसका इफेक्ट देखा जाता है, और कंट्रोल ग्रुप वह ग्रुप है जिस पर कोई ट्रीटमेंट अप्लाई नहीं किया जाता। तो दो तरह के ग्रुप्स होते हैं, और ये फर्स्ट मेथड जो हमारा बिफोर, आफ्टर, विदाउट कंट्रोल ग्रुप, इस मेथड में कंट्रोल ग्रुप नहीं होता, सिर्फ एक ग्रुप होता है और वह ग्रुप है एक्सपेरिमेंटल ग्रुप, जिसको हम टेस्ट ग्रुप भी कहते हैं। यहाँ पर हम एक टेस्ट ग्रुप और एरिया सिलेक्ट करते हैं और डिपेंडेंट वेरिएबल को मेजर करते हैं ट्रीटमेंट के इंट्रोडक्शन से पहले और ट्रीटमेंट के इंट्रोडक्शन के बाद, और उसका इफेक्ट देखा जाता है कि ट्रीटमेंट का इफेक्ट कितना आया है, ट्रीटमेंट के इंट्रोड्यूस करने से पहले क्या इफेक्ट था और बाद में क्या इफेक्ट है। So this design can be represented with the help of a conceptual diagram. Let us understand it with the help of a conceptual diagram. We are taking a group of students of MCOM class. हमने MCOM class के students का एक ग्रुप लिया है जिस पर हम ट्रीटमेंट का इफेक्ट देखेंगे, बिफोर द ट्रीटमेंट एंड आफ्टर द ट्रीटमेंट। अब यहाँ पर हमारा ट्रीटमेंट क्या है? न्यू टीचिंग मेथड। पहले हम स्टूडेंट्स को एक सेमेस्टर में ओल्ड टीचिंग मेथड से टीच करेंगे और नेक्स्ट में हम न्यू टीचिंग मेथड इंट्रोड्यूस करेंगे और उसका इफेक्ट देखेंगे। सो हियर द स्टूडेंट्स ऑफ एमकॉम क्लास, उनको एक सेमेस्टर में हमने ओल्ड टीचिंग मेथड से टीच किया, उनकी एग्जामिनेशन ली गई और आफ्टर एग्जामिनेशन देयर परफॉर्मेंस इज एक्स। दिस परफॉर्मेंस इज बिफोर द ट्रीटमेंट, मींस न्यू टीचिंग मेथड इंट्रोड्यूस करने से पहले ओल्ड टीचिंग मेथड से उनकी जो परफॉर्मेंस है दैट इज एक्स and their mean score is 50/100. Now the new teaching method has been introduced and we will judge the performance of students of MCOM class. यहाँ पर new teaching method introduce करने के बाद उनकी examination ली गई और उनकी performance judge की गई, say that performance is Y and their mean score is 75/100. तो एक सेमेस्टर में हमने उनको old teaching method से teach किया और उनकी परफॉर्मेंस और उनका मीन स्कोर है 50/100, और नेक्स्ट सेमेस्टर में जब उनको न्यू टीचिंग मेथड से टीच किया गया उनकी परफॉर्मेंस थी Y, उनका मीन स्कोर था 75/100. Here the blinking has been used so that you can memorize it better. And the treatment effect, अब यहाँ treatment effect क्या आया? Y minus X. Y means the performance after the treatment and X minus performance before the treatment, that is X. तो यहाँ पर स्टूडेंट्स की परफॉर्मेंस न्यू टीचिंग मेथड इंट्रोड्यूस करने के बाद क्या है? Y है, एंड ट्रीटमेंट इंट्रोड्यूस करने से पहले उनकी जो परफॉर्मेंस थी वो है X. तो यहाँ पर हमने उनका ट्रीटमेंट इफेक्ट देखा है बिफोर एंड आफ्टर, बिफोर द इंट्रोडक्शन ऑफ द ट्रीटमेंट and after the introduction of the treatment without control group.
Hello students, we need to stop it here. The video will be continued in the next lecture.